In this video, we will have few concepts and problems from number theory for doing problems in competitive examinations. And the topic that we are going to concentrate more is on greatest common divisor. Now, what is number theory? Number theory is a branch of pure mathematics. It mainly deals with the properties of integers and in particular prime numbers. So now what do you mean by a prime number? A prime number p is a positive integer greater than 1 whose only divisors are plus or minus 1 and plus or minus p. And p, q, r, these are the letters that are normally used to denote prime numbers. Now if you consider 2 is the only even prime number. We also have 3, 5, 7, 11 and so on. And we have n square plus 1 for smaller values of n to be prime numbers. N square plus n plus 41 if n is less than 40. N square plus n plus 17 if n is less than 16. 2n square plus 29 if n is less than 29. N square minus 79n plus 1601 if n is less than 80. 2 raised to 2 power n plus 1 if n is less than 5. And if you want to know, suppose you have got a number, you would like to know whether that number is a prime number quickly, then you can visit this website. So if you go there and enter a number, see, suppose I enter this number, say 1001. If I enter this, I just want to know whether it is a prime number or not. It says that it is not a prime number. It has got these as the factors. Now, suppose I have this number, say bigger number, then again it calculates and it says that it is not a prime number, and you have the factors to be this. And instead, suppose I consider this, then it says that it is a prime number. So like that at random, see 3, 2, 6, 7, 8, something, it ends with 8, so naturally it is not a prime number. So suppose we consider this one. It says that it is not a prime number. So you can type numbers and you can check whether it is prime or not in this website. And here we have a list of 95 prime numbers between 2 and 500. And in this, suppose I want to know, say 45th prime. What is the 45th prime? Then in this row, in this column, you find that 197 to be the 45th prime. Suppose you want to know 72nd, then 72 here, so you have 359. So you have in a website that up to 1000 prime numbers. Okay, so that you can see from the website, maybe from Wikipedia. Now we have this definition. This definition is needed when we want to have justification, or when we have a result, how to establish that result. So for that, certain basic definitions that we need to know. There are many definitions. Some of them we will see. A number a, which is different from 0, a non-zero number, is said to divide a number b, and it is denoted in this way: a divides b, straight line it should be. A divides b if b is multiple of a. B is m times a, where m is an integer. For example, 2 divides 6 and you write 6 as 3 into 2. Similarly, 3 divides 6 and you write 6 as 2 times 3. So m times a divides b. How do we write that? B is equal to m times a. M is an integer. If A divides B, then A is called a divisor of B. So all these are simple concepts. So from this we see that 2 and 3 are divisors of 6. Even 1 and 6 are divisors of 6. Now again it's a very simple result. If A divides B and A divides C, then A divides B plus or minus C. Here we have established it for the difference. Even for addition, that this one can be proved. So A divides B, A divides C, we have to show that A divides B minus C. If A divides B, by the definition, B must be written as M times A. A divides C means C can be written as N times A. So B minus C, when we compute, it is MA minus NA, and taking M minus N, A out, we have M minus N into A. This is an integer, this is an integer, the difference is an integer, call it as some K. So you have B minus C to be K into A. So the definition always holds in both ways. Whenever you have A dividing B, you can write B as M times A. And whenever B is M times A, then this A must divide B. So definition means you can go from here to here and from there to here. So you have B minus C to be K times A, which means A must divide B minus C. So that is what is written here. Next we have the definition of composite number. Whenever you have a number n being written as A into B, where A, neither A nor B is 1 and divisors of n, then n is called a composite number. A simple example, 6 is a composite number. Next we have the greatest common divisor. A positive integer C is said to be the greatest common divisor of A and B if C divides A and C divides B, and if D divides A, D divides B, then D must divide C. See, from the wording itself, the conditions can be remembered. So you are saying that C is the GCD of A and B. So common divisor in this, greatest common divisor. So first of all, we must have C to be common divisor. So C must divide A as well as B. So common divisor of A and B, it should be. So C you have written. And you have to say that that is the greatest. So that means if any other divisor, say D of A and B you have, D is any other divisor of A and B, then if this has to be the greatest, what naturally we need to have? D must divide C, only then this can be the greatest. So from the definition itself, the conditions can be remembered. First condition, common divisor. Next is greatest. So for that, if I have to say that this is the greatest, I must find someone else to say that he is the greatest. So if I have any other person doing the same thing, if that person comes under me, that is D divides C means, then C must be the greatest common divisor. The notation for that is, this is the notation. It should not be read as ordered pair AB. It should be read as C is equal to, and this notation means GCD of A and B. You cannot have an ordered pair to be equal to a single number. So from that itself, you should know that it should not be read as ordered pair. Now we have an example. Suppose we are given two numbers, say 6 and 10. We would like to know what is the greatest common divisor. So first we will list out the divisors. We have for 6, 1 to be a divisor, 2 to be a divisor, 3 to be a divisor, and 6 to be a divisor. And similarly for 10, 1, 2, 5 and 10. These are the divisors of 10. So the common divisors are 1, 2, that is all, 1 and 2. Of the 2, namely 1 and 2, 2 is the greatest. So you have the greatest common divisor of 6 and 10 to be 2. Then one more, GCD of 12 and 28. So you have the divisors of 12, namely 1, 2, 3, 4, 6 and 12. These are divisors of 12. And for 28, you have 1, 2, 4, 7, 14, and 28. So what are these are the divisors we have listed for 12 and 28. Now common divisors. Who are all common divisors? 1, 2, 4. We don't have 3. We have 3 here, but no 3 here, but 4 we have here. So nothing else is common. So among the common divisors, namely 1, 2, 4, 4 is the greatest. So the greatest common divisor of 12 and 28 is just 4. Now a few methods that are available to find the GCD of two numbers. They are listing factors, what we have mentioned just now, and Euclidean algorithm that can be used, or prime factorization that can be used, and using LCM. There is a formula that LCM into GCD of two numbers is equal to product of the two. So depending on the context, they can be used. One of these 4 methods can be used. So first we will see the listing factors. So in this case, 12 and 18, for example, they are considered. So here this is the method. List all the factors of each number. For both the numbers, you list the factors. Identify the common factors. Identify the common factors. And choose the largest of the common factors. Choose the largest of the common factors. And that is the GCD. So common factors, this is the largest. So you have 6 to be. So if I consider 12, these are the factors. 18, these are the factors. Common divisors we have got. Common factors or common divisors, you can call them as. And among the common divisors or factors, 6 is the greatest. So GCD is 6. Now again we consider the same 18 and 12, but with Euclidean algorithm. So start with general procedure is this. Start with two numbers A and B. Divide the larger number A by the smaller number B. Whichever is smaller, you name it as B. Whichever is larger, name it as A. Then if the remainder S is 0, you're dividing the larger by the smaller. And suppose you have the remainder to be some number, name it as S. If it is 0, then B itself becomes the GCD. If the remainder S is not 0, divide the smaller number B by the remainder S. Now that you have got B and S, so you perform the same operation with B and S. So this process should be repeated until the remainder is 0. So the last non-zero remainder is the GCD. So here we'll consider this one, 18 and 12. When you divide 18 by 12, you have 1 to be the remainder. We have got the remainder to be 6. You have the remainder when you divide 18 by 12 to be 6. Now this is S, right? So you're applying B to B and S. Again this Euclidean algorithm. So 12 and 6. So you have the remainder to be 0. 2 times it goes here, it only 1 time it goes, and so the remainder is 6. Here it goes 2 times and the remainder is 0. So this is the smallest one. So you have A, B, and then you have S. So now for B and S you are applying. So B and S. And the remainder you are getting S to be S prime if you can call. So that is 0 means whichever is the smallest one. This is the divisor, S. So that becomes the GCD. So this is using Euclidean algorithm. Using that we can find GCD. And then another method, prime factorization. So find the prime factorization of both the numbers. So we have considered 12 and 18. We can write it as 4 into 3. 4 can be written as 2 into 2. And here 2 into 9. So you can write 9 as 3 cross 3 into 3. So 18 is 2 into 3 into 3. Now, identify the common prime factors. What are the common prime factors? 2 and 3 are the common prime factors. Multiply the common prime factors. Raise to the lowest power, they appear in either factorization. So in this case, you have only one, so there is no problem. So when you multiply these two, you have this. Suppose you have here 2 cube and here 2 square, means we will be considering 2 square. So multiply the common factor, raised to the lowest power, they appear in either factorization. So that is the meaning of that. So in this case, we have that to be here 3 square, here 3. Smallest one means 3 only we have. Here 2 square, here 2. Smallest one 2. So you are multiplying them and you are getting this. And the next one is, this is what the result, very famous result, that if you are given two numbers A and B, then it can be written as LCM of A and B and GCD of A and B. So LCM of A and B and GCD of A and B, the product gives you this. So if you want to find GCD, divide this product by the LCM, so you get GCD. So that is what is explained here. Find the LCM of the two numbers. Given two numbers, find the LCM. Multiply the two numbers together, then the A and B, if you have taken, multiply them. So this is what you have. Divide the product by the LCM. So when you divide the product by the LCM, you get GCD. So you get the GCD. So LCM of these two is 36 and product of the two numbers is this. And when you divide the product with this, you get 6. So GCD is 6. So definitely of all the methods, see, this is the situation when you are given in the question this and this. So that easily you can find this. But otherwise, this method, that is either prime factorization or Euclidean algorithm. So these are the two methods with which you can easily find the GCD. This is the, if the context differs, that is, you are given the product. You are not given A and B separately. You are given the product, you are given the LCM. So in that context, you have to use this method. So finally, we have, when do we say that two primes are relatively prime? Two numbers, when do you say them to be relatively prime? So the numbers A and B are said to be relatively prime to each other if the GCD is 1. So if you consider, for example, 12 and 19, you don't have any common factor. So you have the GCD to be 1. And when you consider 7 and 17, both of them are prime numbers, so naturally GCD is 1. Here one is prime, the other one is not prime. But you don't have any common factor and therefore GCD is 1. So in that case, what do we say about those two numbers A and B is they are relatively prime to each other. Thank you.